Okay, this is number 9 on our Calculus 1 logarithmic and inverse trig function derivative lab. And this page in particular, I'm telling you to use logarithmic differentiation to complete. So I do know that you could do the product rule here and do it that way as well, but I'm asking you to use logarithmic differentiation. So this is the method. When I ask you to do that, you're just basically going to natural log both sides. And so I have the natural log of y equals, and because I'm natural logging this side and they're multiplied together, you can pull it apart with addition and say that's the natural log of tan theta, okay, plus the natural log of, and I'm just going to say this is 2 theta plus 1 to the 1/2 power, because that's what a radical is. And then I'm going to use another log rule and bring the 1/2 down. So as soon as I actually log it, you can use your log rules to expand this, and then we'll do the derivative of natural log. So this would be 1/2 natural log of 2 theta plus 1. And remember, that is not the power rule. That is just using log rules to expand it. So now I've got it fully expanded. Now, only here do I start doing the derivative. So the derivative of natural log of u is 1 over y dy d theta, because that's the variable in this one, is 1 over u. So this is my u, 1 over tan theta. And the derivative of tan theta is secant squared theta. So plus 1/2 times 1 over 2 theta plus 1, because it's 1 over u, times u prime, and u prime in this case would be a 2. Now the cool thing with this, I see the 2's cancel out, and I can put this on the numerator and that type of thing. And so I end up with, ready, 1 over y dy d theta equals secant squared theta over tan theta, okay, plus 1 over 2 theta plus 1. All right, now what we have to do now is solve for dy d theta. So I'm going to multiply both sides by y. And when I do that, the y is what is up here. So I have dy d theta is, it's tan theta, okay, times radical 2 theta plus 1, that's my y, times secant squared theta over tan theta, okay, plus 1 over 2 theta plus 1, which this is the derivative, that is correct. But the only cool thing that you can see now is you can actually take this and distribute this through. And if you do that, do you see how the tan thetas will basically cancel out on this first term? So I end up with dy d theta. So I'm actually going to distribute this whole term right here, here, and here. So when I do that, the tan thetas will cancel out. So you have secant squared theta, okay, radical 2 theta plus 1, or you can put the radical 2 theta plus 1 in front, it doesn't matter, plus, now this is 2 theta plus 1 to the first power, and this is to the half power, so you end up basically on this one getting tan theta in the numerator, and then I have, these will cancel out, well this will cancel out, and there'll be a radical left in the denominator. So that is how we got to that. So that is number 9.